Alright, hello. In this video, I'm going to be talking about the basics behind the basics behind predicting products. So, when we talked about reaction types, we introduced 5 main kinds. Now, technically, depending on who you talk to, there are more than that, but there are 5 basic kinds of reactions, okay? Synthesis or composition, decomposition, combustion, double displacement or replacement, depending on how old you are, and single displacement or replacement. And single actually has 2 variants, which are a cation replacement and an anion replacement. Now, composition and decomposition, or synthesis and decomposition, they don't, you can predict products for them, but you've got to know a heck of a lot more than we are going to get into in this class. So we're going to pretend those don't exist. So we're only going to be predicting products for for double replacement, single replacement, and combustion. And we are going to start with double replacement, because double replacement is the easiest, because you don't have to figure out what is going on as much in a double replacement reaction. So there are 2 components to this in a double replacement predicting products. First, you have to split your reactants up, and second, you have to put them back together but make something new. So the first part of this will be going over splitting them. The second part will be going through putting them back together. If you do not understand the rules of ionic naming and ionic formulae, this will not make sense, and you need to go and study that more first. Okay, so if you're watching this and you're going, why is that there? Where did that come from? Then you probably don't understand ionic well enough, and you need to go back to that. And everything we do pretty much, except for combustion, is ionic. So you have to understand those ionic rules. So that's what we're going to be going through. So, yeah. We are going to start off by going through worksheet 5.3a, and then later we'll go through 5.3b, which was on the back. So, without further ado, let's get to it. Alright, so we are given, number 1 on this worksheet, we are given the reactants of NaOH plus Li2O. And we need to split these 2 compounds up into their constituent ions. So we need to identify, or we need to determine, the cations and the anion in both compounds. And we have to figure out which subscripts matter and which ones do not. Okay, so here is your quick, easy tip for subscripts. The only subscripts that do not go away and cannot go away are subscripts that are part of polyatomic ions. Okay, so in SO4, the 4 is part of that polyatomic ion. If you get rid of the 4, it's not sulfate anymore. Okay, sulfate has to be SO4. There have to be 4 oxygens. So if a compound has sulfate in it, you can't get rid of the 4 when you split it up. But in this, Li2O, Li2 is not a polyatomic ion. So that 2, it doesn't matter. It goes away. When we split this thing up, we don't care about that 2. Now, I am going to be using, oh man, I really want to use the same colors that I did for the version of this I did in class, but I cannot remember which one was which. I am pretty sure that blue was positive and red was negative. So I'm going to roll with that and apologize if I've got these backwards. So, NaOH. The cation in this, well, first off, cations are always written first and have to be positive. There are 3 things that can be cations. Ammonium, which is a polyatomic ion. Hydrogen, because of course. and any metal, which are the fun ones. Okay, so if it has to be either ammonium, hydrogen, or a metal to be a cation. If you're trying to figure out where is the split, if the first element is a metal, that's the cation. Okay, so the split here has to be between Na and O, because the Na is a metal. So our cation in our first compound is Na. But Na, in order to be an ion, it has to have a charge. Well, what's the charge of sodium? Well, it's in group 1, so it has to be +1. So I'm going to write Na+. The anion is everything else. So OH, what's the charge of OH? Well, it's a polyatomic ion. Polyatomic ion OH is a -1 charge. You could also figure that out based on the fact that the sodium was a positive charge. Now, for the second one, we already said this 2 doesn't matter. We're going to pretend it doesn't exist. So Li, again, has to be the cation because it's a metal. And it's in group 1, so its charge is +1. Oxygen here, or oxide, because it's a single simple anion, has to be the anion. That's the wrong marker. And oxide, as you memorized, has to have a charge of -2. And that is splitting. That's really all there is to it. I'm going to do a couple more of these to show you some different things you might run into, but that's it for the most part. I'm going to do 2 or 3 of these. I'm going to jump around a little bit because I want to show you a couple of different things. Let's do number 3 next. Number 3 looks like a good pick for next. So 3 is Li2SO4 plus no, that's number Al2O3. All right. So this time, once again, cation is the metal. Both of these are metals, so these have to be the cations. Okay? So Li, is Li2 a polyatomic ion? No, we already said it's not. There is no polyatomic ion with Li2, or at least not one I had you memorize. So as far as you're concerned, there isn't one. So Li has to be +1, which means everything else has to be the anion. So SO4, and the 4 here has to stay. Why does this 4 stay? Well, this 2 and this 2 don't. Well, because sulfate is a known polyatomic ion. It's one you're supposed to recognize when you see it. And its charge has to be -2. Why -2? Well, because that's what your polyatomic ion list tells you. Or you can memorize it. I don't know how many of you did that. Next we have Al2O3. Again, starts with a metal. The metal has to be the cation. So Al +3, because aluminum is one of the 16 I told you had to memorize, and it's a +3. And then O3 is not a polyatomic ion. So it has to be oxide again. So it's going to be O, -2. Because again, O is one of the ones you were supposed to memorize. It has to have a -2. Now, let's find... Let's go down to number 5 next. Yeah, get this up a little higher. All right, so on number 5, we have NH4Cl plus MgOH2. All right. Well, nitrogen is the first element. That is not a metal, which puts us in a bit of a predicament. So, but what are the other 2 things that I told you could be the cation? Hydrogen, or ammonium. Well, NH4 is ammonium. So that means this 4 is part of a polyatomic ion, so it stays. So NH4 plus is our cation in this compound, which means then chloride, Cl minus, has to be the anion. In the next compound, Mg is our cation, and it has to be a +2. And that means that OH2 is the anion, right? Well, not quite. Is OH2 a polyatomic ion? No, it is not. OH is a polyatomic ion. OH2 is not. Okay, so the anion here is OH negative. The 2 doesn't necessarily come across. And with polyatomic ions, this is a little easier to pick out, because if it's a polyatomic ion and the subscript is outside of parentheses, you ignore that 2 in those parentheses. They are not part of a polyatomic ion. They are there to balance the charges. Just like we have -1 and +2, we need 2 of these to make it positive. It's the same reason there were 2 Li's and 1 oxygen up here, because we needed 2 +1s to cancel the 1 -2. It takes 2 of these to equal 1 of these. It takes 2 of these to equal 1 of these. It takes 3 of these to equal 2 of these, because 3 times -2 is -6, 2 times +3 is +6, so those cancel. You have to watch for those charge balancing subscripts. Okay, that's all I'm going to say on splitting. So work on the rest of this worksheet. That is, again, 5.3a. And then you can go into the notes, or go into, good Lord, you can go into Canvas to find the key, or I probably have a paper key if you're in class that you can look at there. Would recommend pausing this and finishing the front of the worksheet before you try to watch the second half of this, where I'm going over the back. Okay, I'm going to pause recording and erase all this so I'm ready for the second half. So, yeah, pause now, because I'm not putting the answers up here. I'm just going to dive into the next thing now. All right, cool. And I'm back, and probably my face is lagging, but we're going to roll with it. Okay, so now we're going to do the back of this worksheet, which is putting the anions and cations back together. Okay, now for the first couple of these, I'm going to use the bolded information that's in the middle here. Okay, so this is what you're given to begin with, and then this is what it's split into. So for the first one of these, I am going to start with this, and I may go ahead and do it with the second one as well. But then we're going to start doing it with just the reactants so that you can see how to do this. Hang on. Sorry, my alarm just went off telling me that it's time to get up. Where was I? Oh, I'm going to do the bold parts for the first couple, and then we'll do 1 or 2 with these so you can see both. Now, you're going to get more chances to practice this aspect where you just use the reactants and don't have this in the next worksheet. So if the second 2 don't make sense, just do this. I'm giving you these for a reason, so you can practice the part where you're just putting them back together. Okay, if that's what you need practice with, then that's what you should do. All right, so I am going to write out our ions here. So we have NH4 plus, which was with OH minus, and we have H plus, which was with SO4 minus 2. Okay, now I have rearranged these a little bit. I shouldn't do that. Hang on, I'm going to rewrite this the way it is in the actual list. Pause. All right, so this is the way it's actually written. Now I have underlined them like this to show you something. Okay, if you look at the actual reactants, and this is really important, you have to look at the actual reactants. NH4 was bonded to OH on the reactant side before it was split, and H was bonded to SO4 negative 2, or SO4. H was bonded to SO4. Okay, I have indicated this because that's really important when you start putting them back together, because we are trying to indicate that a reaction happened. Okay, in order for a reaction to happen, the products have to be different from the reactants. Okay, so OH can't bond to NH4. Otherwise, we would just end up with the same products that we had as the reactant side. Nothing would have happened. No reaction took place. Likewise, cations can't bond with each other. These are both positive. There's nothing there to make that bond happen. Cations can only form bonds with anions. That means there's only one thing that each of these can pair up with. Okay, so when we're looking at our products, we're going to start with NH4. And by the way, I always recommend that we have 2 blanks on our, throwing markers around. We have 2 blanks for our products. I always recommend that you start by writing in your cations in the same places that they were on the reactants. So if you look here, NH4OH is the first reactant, and H2SO4 is the second reactant. So I'm going to write NH4 in the first blank, and I'm going to write H in the second blank. I'm putting them first because they are cations. They have to be written first in whatever compound, and they can't bond with each other. So this way, we don't have to worry about accidentally putting the cations together. This one's in the first blank because that's where it was on the reactants. This one's in the second because that's where it was in the reactants. Now we need to add anions to the cations. Well, NaOH can't bond with OH because they were already attached to each other. So NH4 has to bond with SO4 instead. So I'm going to put SO4 in the first blank, which means that OH has to go in the second. But we're not done yet. And this is why this is the annoying part. You have to charge balance your products. You have to make sure that the charges here sum to 0, and ditto over here. So what is the charge of ammonium? Well, it's +1. What is the charge of sulfate? Well, it's -2. Do +1 and -2 cancel? No, they do not. They never will. That means we need to charge balance this. Now, if swap them and drop them makes sense to you, that's what you do. Otherwise, we need 2 of these in order to get +2 and cancel the -2. So we need to put parentheses around NH4 and add a 2 subscript. Okay, now for hydrogen and hydroxide, the charge of hydrogen is +1. The charge of hydroxide is -1. Those cancel, no subscripts needed. By the way, you only add parentheses if you're adding a subscript to a polyatomic ion. Okay, that's important. Now I'm going to do one more of these. So I'm going to pause this and write it out because the video is getting long. And then I'll do 2 where we just start from the reactants. And then you can decide how you're going to go about it. So, yeah. All right. So now this time we have Fe +2, Ca +2, OH minus, and CO3 -2. And again, the Fe was bonded to the OH, and the Ca was bonded to the CO3. Now, we are going to talk about how you figure out this number when you are not given it in the next one that we work. Okay? But again, if you know ionic naming and ionic formulae, then you should know how to figure it out. So it should be review. And I'm going to be progressing under the assumption that it is review. So we have to first put our cations in. Well, Fe is the first one, is in the first spot on the reactant side, so we're going to put Fe. I'm going to go ahead and write +2 above this time, save some time later. Then Ca goes in the second. And Fe was bonded to OH. So Fe cannot bond to OH. It has to bond with the CO3. So CO3 has to go here. That's a -2. And the OH has to go here. That's a -1. Now, +2, -2, cancel, no subscript needed. This one is done. However, a +2, a -1, they do not cancel. So we need 2 -1s. So we need to add a 2 subscript. But once again, polyatomic ion, we need parentheses to indicate that that 2 doesn't just apply to the H, it applies to the O as well. Because the whole polyatomic ion, there's what there's 2 of. Alright, so that is that. I'm going to, that was number 3. I meant to say that sooner. Sorry, that was number 3. I am going to jump down to number 9 next. Okay, I'm going to do number 9 as the next one. And we're going to skip the ion stage and just go straight from reactants to products. So yeah, watch one of those and then decide if you want to see the rest. All right, as I said, this is number 9. So we are going to dive right into this because this video is getting long and I don't want it to drag out. So cation has to be iron because it's a metal and it's written first. So we are just going to transcribe that Fe over here. Likewise, K has to be the cation on the second one. K2 is not a polyatomic ion, but Cr2O7 is. So this is the cation, and this whole thing has to be the anion. So I'm going to put the K over here. Now, we need to know the charge of both of the cations. Now, potassium, we just know is +1 because it's in group 1. But iron's one of those annoying ones where we don't actually know what the charge is going to be. So you can either undo your swap them and drop them, or you can recognize that O has to be a -2, and there are 3 of them, so there's -6. So what times 2, because that's what that is, will give us +6. Well, that has to be +3. So the iron has to be a +3 charge. So I'm going to write +3 right there. Okay, now our anions. Well, the rest of these have to be the anions. But again, this 3, that's not part of a polyatomic. There is no O3 polyatomic ion. It's just oxide again. So this is O, but it's attached to the iron right now. This is iron. It's attached to the iron, so it has to be attached to the potassium on the other side. So I'm going to write the O over here, KO. I'm tired. All right, and that is a -2 charge. Okay, and from there, Cr2O7 is again a polyatomic ion. So the 2 and the 7 we do not leave behind. We take those with us because polyatomic ion, not polyatomic ion. Polyatomic ion, not polyatomic ion. Stays behind, comes along. Okay, so Cr2O7. And that is a -2 charge, which you can figure out by looking it up on your polyatomic ion list. Now, neither of these charge balance, so we have to balance both. So we can swap and drop to get that. So the 3 here has to go here. The 2 here has to go there. That Cr, or that C, needs to be written over to the side a little bit, so I have room. Pretend that's a C. All right. So the Fe just gets the 2, because this is not a polyatomic ion. But Cr2O7 is a polyatomic ion. So we can't just put the 3 here, then it looks like there's 73 oxygens. We have to add parentheses here. Versus over here, -2, +1. Swap them again, so it has to be K2O. Alright, I'm going to do one more of these. I think that was the last one with the transition metal. No, the last one does, but I want to leave you one. So I'm going to do number 10 next. Okay, number 10. So, once again, just draw myself, we are going to start off with Ca and NH4. Ca is to be the cation because it's a metal, so it's going to go straight into the first blank. NH4 is a polyatomic ion. It's ammonium. It's the only polyatomic ion I told you could be a cation. So this, without the 2, because that's outside of parentheses, without the 2 is going to go to the second blank. Okay, Ca, oh, I forgot to write the charges. Ca has to be +2 because it's in group 2. Ammonium is +1, which you find out by looking at your polyatomic ion list. Then we have CO3, which is a polyatomic ion with a -2 charge. Currently it's bonded to calcium, so it is not allowed to bond to calcium again. It has to go over here. So CO3, and that has a -2 charge. SO4 then has to go with the calcium, so SO4. And that is, again, a -2. Both of those you get off of your polyatomic ion list. Now, charge balancing. +2, -2. Cancels. This one's done. +1, -2. Does not cancel. So this time we have to put parentheses around ammonium, and we have to put that 2 back on. Okay? Now, if this was a -3, then we would have to write a 3 here instead. Okay? So bear that in mind. That is it for this video. I'm going to stop there. I would suggest, again, you check the key as you go through, because the key has several more examples worked out. Like it has all, I think, 22. Yeah, all 22 of these worked out with the answers. So you can see from there what's next. Now, the next thing we're going to do, tomorrow, you'll get another worksheet with, I think, 10 double replacement problems that we'll work first. Then there are 10 combustion problems that we're going to go through. And then there are 20 single replacements, because 10 of them are cation replacements and 10 of them are anion replacements. And we'll talk about those in the next video. So I'm going to sign off here. Have a wonderful night, and I will see y'all next time.